Hi, I'm John Paulraj, and this is part 14 of the Complete Solution series for May 2025 IB Mathematics Applications and Interpretations, Paper 1, Time Zone 1, and this is for the HL students only, so let's roll. All right, this is question number 14 and it says that consider the following functions. L1x is 14.8. Sine of 0.35x plus 1.27, and L2x is another function, 18.5. Sine of 0.35x minus 2.36. They want us to write down both of these functions in the form imaginary part of a complex number. So basically they want you to, they both are the imaginary part of a certain complex number, okay? And both of these functions need to be written in that form. So it's actually 2 points and, can you see that? Yeah, 2 points and you got to identify the complex number whose imaginary part is, given in that form for L1x and L2x. This is basically the polar form of a complex number, right? So we'll write down the answer like this. L1x is the imaginary part of a complex number Z1, which is basically 14.8 e to the power of I theta. Don't forget that I, that's important. I, and oops, what's going on? I, and the term 0.35 x plus a 1.27. Okay, so that's basically that r is theta. Okay, that r is basically that 14.8 that you have got here, and that's e to the power of I theta in the polar form is basically the cos theta plus I sin theta. I sin theta or the sin theta part is what is the imaginary part as they're given here, right? So don't forget the I. Now remember, they said write both functions in that form, and there they've separated the e's. Can you see that? So the x term and the non-x term. Okay, so that's what we will do even here. Okay, so what we're going to do is that we'll say this is basically 14.8 e to the power of I 0.35 x. Does that look funny? Maybe you should write it as 0.35 xi. Okay, one second. 0.35 xi and then times e to the power of 1.27i. Okay, Lx is the imaginary part of that, and so L1x, did I say Lx? I think I said Lx. L1x is basically the imaginary part of this number. Just copy it down. 14.8 e to the power of 0.35 xi times e to the power of 1.27i. Don't forget that I. Okay, so in the same way we can write down L2x. Similarly, L2x must be equal to the imaginary part of it. Now you can use that without showing the whole working. You can, because you've written down the explanation for the first part and it's just 2 points, right? So you can write it in the same way. What is L2x? 18.5. I'll just write it down. 18.5 e to the power of the x part is the same actually, 0.35x. So 0.35x. Don't forget that I times e to the power of, this one has got a negative 2.36, negative 2.36i. Okay, now this is imaginary part of a second complex number Z2. Maybe I'll mention that because I think it'll become easier for the part B. Because for part B, I think we're going to add, okay? Just see the part B. It says the sum of L1 and L2, you're going to add, right? So it'll be easy if you add Z1 and Z2 as complex numbers and then pull out the imaginary part because it can be expressed in that form, right? The original form. And use your answer to part A to find the value of Q and R, okay? So which is the imaginary part of another complex number Z2, and let's just write that thing down. 18.5 e to the power of I, and the term is 0.35x minus, what is this, 2.36, right? Sometimes I can't read my own handwriting. Okay, if my handwriting is bad, you should mention that in the comments also. 18.5, did I get that right? Let me just check that again. 18.5 e to the power of I, 0.35x minus 2.36. That's good. So far, so good. All right. Now, why did I... This is all that is required in the answer for this first part, okay? This is all that's required. Why did I do this? Is because, it's going to help me add the two complex numbers, which is what's required for part B. All right. Although we are going to use a calculator and I'll show you that functionality, but it just helps. So let's just continue the part B here, somewhere here. And so the part B is, we'll start with Z1 plus Z2. Okay, so Z1 plus Z2. Remember, these are the complex numbers, and we are just interested in the imaginary part of the sum. Okay, so Z1 plus Z2. Just let's write it this way. Maybe you can even separate this, just as we separated that, right? Yeah, it'll be easy if you separate the e's. So I'm going to take one more step here. 18.5 e to the power of 0.35 xi times e to the power of minus 2.36 I. Okay, we'll use this form just as we have here. So Z1 plus Z2 is now 14.8 e to the power of 0.35 xi times e to the power of 1.27 I. Can you see this? Oh, you can't. Okay, there you go. I think that's better. And plus the second complex number, which is 18.5 e to the power of, the first term is strangely the same, 0.35 xi, and times e to the power of minus 2.36. Did I get that right? I, don't forget that I. Yeah, I think that's good. That's good. Okay, now the way we'll do it is, I mean, you could enter the whole thing on the calculator, but let's play it smart, because if you look at it, they have a, this part is there, right? 0.35x, that's there. So maybe let's try and factor that out first, okay? That comes from this part. It comes from this part, okay? So we'll factor that out, and let me use another color for that part. So I'll take e to the power of a 0.35xi as the common factor, and then what remains is 14.8 e to the power of 1.27i plus 18.5 times e to the power of a negative 2.36i. Now, when you enter this in the calculator, and we'll enter only this part, okay? We'll just evaluate this because, as I said, we need that part as it is, okay? We'll just evaluate this part. When you enter this in the calculator, it'll give you the complex number, and from there we'll have to deduce what is the r and the theta correspondingly, okay? So just if you look at what is important in this particular question is knowing how to write the complex number, both from the from the Cartesian form, polar form, and then the Euler form, okay? The Euler form also is important in this case. Quickly jumping to the calculator, then we will insert a calculator page, meaning a new problem first, and there's a calculator page there. And I'm going to enter just that term, okay? Just that term, that 14.8 e to the power of 1.27, okay? So on this screen out here, this is where I'm going to say, I need a 14.8 first, okay? So let's just get that, 14.8 times e to the power of 1.27. Let's not forget the I is along with this pi and all those guys here. And then let's come out of that, plus 18.5 times gain e to the power of, with a negative sign, 2.36i, 2.36, and then we need that I again. All right, there you go. Now, when you hit enter, it's going to give me that complex number, negative 8.75 plus 1.1i, a plus bi form, Cartesian form, as they say for the complex numbers, but that's not what we want, right? We want the polar form, okay? In particular, the Euler form, all right? So what we're going to do is that we're going to try and evaluate, okay? So this one, I can't write it here. Well, let me just write it here so that it'll show the working anyway. So somewhere in the rough, maybe somewhere in the rough, you can say that this, just this term inside is equivalent to negative 8.75 plus 1.1i. All right. Now we want the r, and let's not get confused with this r, because here this r is something else. See this? Okay, I'm not talking that. I'm just talking about the r here, which is basically the square root. When I'm talking about the r, I'm referring to this, okay? R is theta, this r. Okay, remember in our question, the r is something else. You see that? Okay, here the r is basically the root of, it's basically the r is the root of that negative 8.75. Just be the positive only because, yeah, the square of the negative number, and 1.1 square. That'll give me that r. And the theta is basically the tan inverse of 1.1 over that negative 8.75. But we got to be careful. What they've said that the value of theta should be in the within 0 and 2 pi. Okay, so we need to adjust if it's going to give you a negative angle, because negative angle means it's in the clockwise direction. Okay, so we got to adjust that. So let's just check this, and this is what we'll use the calculator to compute for us. Okay, so here we are. I want the square root of a negative 8.75 square. So a negative 8.75 and the square of that, and the square of, what is that, 1.1 square of that, and I hit enter. I'll get 8.82. that should be my R. Okay, that should be my R. So this is basically 8.82. I'm just writing this thing down here. Okay, and then the theta, let me just show you what I just wrote down quickly. That's the 8.82, and that refers to the R. R is theta, that, not the R. Okay, let's just not confuse with the R given in the question. Too many R's in this particular. Not just too many, not too many, just two. But you be clear, okay? This is the R, the modulus, okay? And the theta, all right. Theta is now tan inverse of 1.1 divided by 8.75, 1.1 divided by, and remember it's a negative 8.75, okay? So don't forget that, negative 8.75. And when I hit enter, I get a negative value. How do you compensate for that? Just add a pi to it, okay? You'll get that value, and so that's plus a pi, and that should be 3.02, 3.0, just like that. Okay, so we'll come back to our calculator, and this theta, therefore, is going to be equal to 3.02. This is definitely well within that 0 to 2 pi, because 2 pi is 3. 2 pi is what? 3 point, well within that, man. I mean, because pi is 3.14, so 2 pi is definitely, 6.28, definitely less than that, because that's what they're looking for, right? It should be between that, and not only should it be between, when you look at 0 and 2 pi, it is not negative. That's more important. What we got earlier on our calculator, we got that negative 0.125, right? So it's less than 0, okay? As you can see, it says it should be greater than 0 in the question. So that is why we have to add the pi and consider the angle in its positive sense, okay? So that's the value of R. Let me put it all together now. Remember, we have evaluated just this part, okay? So how are we going to write this? This can be written as the e to the power of 0.35 xi, okay? This is xi, not multiplied by xi, with the modulus here is 8.82, and we have cis theta, right? So we will write it as e to the power of I, and the theta is 3.02. I hope that is clear. Okay, so let's just write it as 3.02 first. 3.02 I. Make sense? Okay, so that part is a cis theta, and you know hopefully you know the conversion between the polar form and the Euler form. Now, why I've done that is because then we can use this, because as I said, I think even in an earlier part, keep an eye on what is given on the right hand side. In the right hand side, meaning where are you headed towards? You want that 0.35x, right? You want that, which is why we've tried to preserve that 0.35x. Okay, now it becomes easy in the sense that we can just collect the terms and say this must be 8.82, and to brackets we have e to the power of 0.35xi and e to the power of 3.02i. I think this is the form they want, right? Let me just check. That's the imaginary form. That's the imaginary form, but we need to write it in this form. Okay, that's the form that we've done for part A. You know, the same thing that we've done for part B, imaginary part of the complex number. So this is the complex number. This is the complex number, and from this we can say this is Z1 plus Z2. The complex number is Z1 plus Z2. Okay, which means we can say imaginary part of Z1 plus Z2 is equal to that L3x, the imaginary part, okay? So which will then be L3x is going to be equal to, are we writing it in that form? We can just write it as 8.82 sine of, okay, 0.35x. Now we can ignore the I because it's the imaginary part, plus 3.02, okay, 3.02. That's it. I think that's about it. Okay, so the main part in this particular question, is there anything else that we've left out? I guess that's it. So we got the value of Q, which was our modulus, and then we got our r. Okay, r in this case, remember, don't get confused, is the angle that they're referring to in this particular question between 0 and 2 pi, and had to be positive. Okay, so we had to make that conversion. So the main part was to know, the how to write a complex number in all forms. I think the Cartesian form, the polar form, and the Euler form. So I hope that this video was useful to you. If it was useful, then please make sure you like this video with somebody and subscribe to my channel. If you visit my channel, you'll find several other videos on my channel. Take a look at them, and if there's any topic, any concept, any question that you want explained, do mention that in the comments and I will make a video for you.